Geometry 7-1, ratios and proportions. So some of the stuff I'm going to write along with you, and some of it I'm just going to have you copy down, and you can pause if you need to. So a ratio is a comparison of two quantities using division. So we're going to see what that looks like in a minute. A comparison of two quantities using division. And it's expressed in these different ways. A to B, or A over B. B cannot be 0. So these are the different ways we express ratios. So you might want to pause and get this down because I'm about to take it away. Because we're going to look at equivalent ratios together. So equivalent ratios, here's an example. 32 over 18. If I were to divide the top and the bottom both by 2, then I get 16 over 9. These two ratios are equivalent ratios. Notice if I divide the top and the bottom both by the same thing, or if I multiply the top and the bottom both by the same thing, then I will get equivalent ratios. So I would like to know what is an equivalent ratio to 1/2, and what is an equivalent ratio to 3/9. So go ahead and do those two. See if you can figure out an equivalent ratio to both of these, and then we'll come back and check your work. All right, let's see. So for this one, if you multiply the top and the bottom both by 2, you get 2/4. And so that is an equivalent ratio. You could also get 3/6. You could get 4/8. You could get 5/10. You can get all of these different things, many possibilities for your answer here to get 1/2, an equivalent ratio to 1/2, or 1 to 2, or 1 over 2. 3/9, if I divide the top and the bottom both by 3, I get 1/3. You might multiply the top and the bottom both by 2 and get 6/18. These are all equivalent ratios here. All right, let's keep moving. Now let's talk about an extended ratio. So an extended ratio has 3 or more quantities. There's an I and an E there. Okay. So here's your example. It might look like this: A to B to C, which you could write as A to B, B to C, and A to C. So these would all be ratios that would be made up of this. So let's do an example. So I've got, we're going to talk about some angles here. And I've got a triangle that is 3 to 4 to 5. This is the ratio of angle measures. So I want to find the measure of each angle. Okay. So if we look up here and we look at these ratios, and we notice that we multiplied or divided the same number by each part of each ratio. So this is both divided by 2, these are both multiplied by 2, these are both divided by 3. And so for this situation, we're going to have a triangle. And this triangle is ABC or AO. On my previous notes, I did it this way. So let's just do it the same way as my previous notes. So let's say this is A and this is B and this is C. So A would be 3 times a number, right? Because up here we're multiplying by a number or dividing by a number. So 3 times a number. B is going to be 4 times a number. And then C is going to be 5 times a number because my ratio is 3 to 4 to 5. And they're all going to be multiplied by the same number in order to up or change the ratio to make an equivalent ratio. Now that I have this all written out, I know that if I were to add all of these angles together, I would get 180 degrees because that's how many degrees the sum of the interior angles of a triangle is 180 degrees. So 3x plus 4x plus 5x equals 180. 5 plus 4 is 9 plus 3 is 12. 12x equals 180. Divide both sides by 12. X equals 15. So now I know what x equals. So this is the number that I'm multiplying each of these by for my equivalent ratio. So I just say 3 times x, which is 15, equals 45. So 45 is a measure of angle A. Angle B is 4 times 15, so that'll get me 60. Measure of angle B equals 60. And then another 15 was going to be C. Measure of angle C is 75. That's 5 times 15 equals 75. So this would be my answer, degrees here. All right, how about you try this one? So I've got sides of a triangle. My ratio is 2 to 2 to 3. Two to 3. The perimeter, so these are the sides. We're not talking about angles this time, we're talking about sides. The perimeter, remember the perimeter is all the sides is added up. Perimeter is all the sides added together, and that is 392 inches. Now I want to know the measure of the longest side. Okay, so follow this example up here. Notice we're talking about sides this time and not angles, but you should still be able to, make a little manipulation here and be okay. The perimeter, all the sides added up is 392. All right, so let's see if you can go ahead and do this try on your own, and we'll come back and try it out. All right, welcome back. So I've got this ratio, 2 times 2 times 3. So I'm just going to draw a triangle. Notice that these two sides are the same. So I have two sides that are the same. And at this point I would say, okay, what kind of triangle do I have if I know that 2 of the sides are congruent? And you would all say, isosceles triangle. Of course, Mr. V. Isosceles. So this is 2x and this is 2x. Remember, I'm multiplying each of these by the same number, x, whatever x is, because I'm going to find the equivalent ratio that gets me to this perimeter. So the perimeter is 392, and so that I'm just going to set that equal to all of these guys, 2x plus 2x plus 3x. I'm going to add these together, that's 7x, 392, divide both sides by 7, so x equals 56. 392 divided by 7 is 56. Now, am I all done? No, I'm not all done. The longest side, so I didn't draw this quite accurately, right? This should be longer than these two sides. It should look more like this. So I didn't quite draw this to scale. This is a more accurate representation of what our triangle should look like. That's okay. We'll keep moving. X is not the answer that I want. I want to know the longest side. This is 3x. How do I know this is the longest side? It's because this one is 3 and these are 2. So 2 times 56 is 112. 3 times 56 is 168. 3 times 56 equals 168. So that is 168 inches is the answer for the longest side here. Let's do one more, you try. And I've got a triangle, EFG, and the ratio of this triangle is 5 to 12 to 13. And the perimeter, so these are the sides. The perimeter is 90 centimeters. Oh, these are the angles. Sorry, these are not the sides. These are the angles. Okay, the perimeter is 90 centimeters. These are the angles. Now, make sure it doesn't say sides there. I would like you to find out what are the measures of each angles. Measure of angle E, measure of angle F, and measure of angle G. Now, they've done something a little bit tricky, or I have allowed them to, whatever. We've been given the perimeter. We're looking for angle measures. The angle measures don't really have anything to do with the perimeter. They kind of do, but not for what we're doing right now. So you can ignore this. This is extra information. So just ignore this perimeter equals 90 centimeters and find my angle measures. Remember, how many angles, what is the sum of the interior angles of a triangle? It's 180 degrees. Okay, go do this one, go. Okay, let's see how you did. So all I'm gonna do here is I'm gonna say 5x plus 12x plus 13x equals my total sum of interior angles is 180 degrees. So I'm going to add these up. 15 plus 5 is, no, 25 plus 5 is 30. 30x equals 180. Divide both sides by 30. X equals 6. And so now I've got x equals 6. That's not my answer. That's going to help me get my answer. So E is 5 times x. 5 times x, which is 5 times 6, 30. F is 12, so 12 times 6 is 72 degrees. And then measure of angle G, G is 13 times 6, which is 78 degrees. All right, so that's what you should have gotten for your U-try. Now we're going to kind of switch gears a little bit here. We're going to talk about properties of proportions. Properties of proportions. So a proportion it is like this. A over B equals C over D. I've got two equivalent ratios, or two ratios are equal or equivalent. So a proportion is two ratios that are equal to one another. And so there's a couple ways to see or to use these. Okay, so you might have heard before about cross products. And in this case, the way we use cross products, we'll use our same example here. What we do is we say the numerator of one times the denominator of the other, and the denominator of this one times the numerator of that one. And so what we get is A times D equals B times C. Now we can go through a little explanation of why that works, but instead we're just going to go ahead and keep moving on here. And we can use these cross products in some pretty cool, for some cool different ways here. So the first way we're going to look at is we're going to solve. And we're going to say 6 over x equals 21 over 31.5. And I need to solve for x. So we're going to use these properties of proportions, which this cross products is a property of proportions. We're going to use cross products in order to solve this. And so what we're going to do is we're going to say 6 times 31.5 and x times 21. And we're going to say 21 times x equals 6 times 31.5. 6 times 31.5 is 189. Then I just divide both sides by 21. X equals 9. 189 divided by 21 is 9. All right, let's do another example. We're still solving here, and then I'll have you do a couple u-tries. Here's x plus 3 over 2 equals 4x over 2. So I'm going to use cross products. That one times that one times that one. 2 times 4x, let's see, I'm just going to rewrite it. 2 times 4x equals 2 times x plus 3. Now, at this point, if you are a fancy math person, you can just say 2, if I divide both sides by 2, those 2's go away. If you're not thinking about it that way, that's okay. We'll just multiply it all out and keep working. So 2 times 4x is 8x equals 2x plus 6. So I've just distributed that 2 in there. Subtract 2x from both sides. I get 6x equals 6. Divide by 6. X equals 1. And I can plug that back up in here and make sure, okay, 1 plus 3 is 4, 4 over 2 is 2, 4 times 1 is 4 over 2, which is 2. So 2 equals 2, yep, it checks out. Let's have you do a couple of these. Negative 4 over 7 equals 6 over 2y plus 5, and 7 over z minus 1 equals 9 over z plus 4. All right, 2 kind of gross looking ones. But these are the u-tries that I have chosen for you. Go. All right, let's see how you did. I'm just going to do the cross products here. 7 times 6 and negative 4 times these guys. So 7 times 6 is 42. Equals negative 4 times 2y plus 5. Okay, so now I'm going to distribute. 42 equals negative 8y minus 20. Make sure you got that negative when you multiply through there. And then I'm going to add 20 to both sides. And I get 62 here equals negative 8y. Divide by negative 8, divide by negative 8. This one is kind of gross. When you divide negative 8 from 62, you get y equals negative 7.75. And then let's do this one. 7 times z z plus 4 equals 9 times z minus 1. So I just multiply that way, multiply that way. So I'm going to distribute here, I'm going to distribute there. 7z plus 7 times 4 is 28 equals 9z minus 9. Now I am going to subtract 7z from both sides, and since we're in geometry, I can do two things at once. I'm going to add 9, maybe I can't do two things at one time. Add 9 to both sides too. So I get rid of this negative 9, and I get rid of this 7z. 9 plus 28 is 37 equals 2z. Now I divide by 2. 37 divided by 2 is, what is it? 18.5 equals z. So don't be too scared if you get a fraction. If you're doing it right, sometimes you get a fraction, unfortunately. All right, so that is that so far. Let's go ahead and do the last bit of this section. And we are going to talk about equivalent proportions. Equivalent proportions. So we just have a couple examples to do after we write a little bit of stuff down first. So equivalent proportions. So if A over B equals C over D, then B over A equals D over C. So all I've done is I've just flipped them, the numerator and the denominator. And C over A equals D over B. So what that means is, so now I've taken these two and put them in the numerator, and I've taken these two and moved them over into the denominator. So this one is a little bit more tricky, but these are all equivalent proportions. So here's something with numbers. 1/2 equals 3 over 6, right? This is 1/2 and this is 1/2. These are equivalent proportions. So if I were to swap these two, I've got 2 over 1 equals 6 over 3. That's still right, right? 2 divided by 1 is 2. 6 divided by 3 is 2. Okay, so those are still equivalent. Now let's take these and make them the numerators. Take these, make them the denominators. So 3 and 6 on the top, and then 1 and 2 on the bottom. 3 over 1 is 3, 6 over 2 is 3, and so these are still equivalent. Kind of a weird thing, but it works. Now let's do a couple examples. Now I am going to actually, instead of write the examples out, I'm going to put them here, just like that. So here's the example. I'm going to read it. You can pause if you want to write it down. Survey of 50 students, 28 own cars. The school total of 755 students, that is a school total. How many students own cars? So we're going to assume that that we have that we can expand this ratio out to 755. So here's what I do. I take the whole 50 students. So this is the whole, or the big number. And then I take the piece, 28, put that on top. And I set that equal to the whole, which is students. So notice I have students on the bottom, 755. And then I have cars on the top, cars on the top. So the whole on the bottom, the piece on the top. Now, I'm going to say that's X. And so now I just am going to figure out, okay, I'm going to use cross products and solve for X. So I'm going to multiply across here and multiply across here. So 50X equals 28 times 755. Ooh, gross. I don't want to do all that. But let's see, I did it last time, didn't I? Yeah, okay. So I just go through, get my calculator and multiply 28 times 755, which is 21140. Divide both sides by 50, divided by 50, and I get x equals 422.8 students. So you're not going to have 0.82 students. So this would be your answer here. This is how many students 422 would be your answer for this question. All right, let's do a U-try here. So this next U-try is students captured 48 butterflies. 3 had tags on the wings. How many would be tagged out of 100 butterflies? So here's the whole, here's the whole, here's the piece, and I want to find the piece for this whole. So see if you can set up this ratio, cross products, solve for x. All right, pause and go. Let's see how you did. Okay, so I'm going to have the whole, which is 48 butterflies, the piece, which is 3 tags, equals 100 butterflies, which is the whole. Oh, and then I need to know how many tags, how many butterflies would be tagged. So tags on top, butterflies on the bottom. Or total butterflies on the bottom, butterflies with tags on the top. You could say it that way. That might be a little less confusing. So I'm going to do cross products here. 48x equals 3 times 100. And then I'm going to divide both sides by 48. So I've got x equals 300 divided by 48. So let's see, what's 300 divided by 48? 6.25. So your answer would be 6. Let's see, is that what I got last time? That is what I got last time. So last time I said approximately 6. And that is 7-1. Good luck on the homework.